This is a tutorial for Microsoft Excel. This video is copyrighted by Douglas Howey. All rights reserved. The program that we're using is Microsoft Excel, and that is owned by Microsoft Corporation. All rights reserved for this company. The table of contents should be listed about here. I'm going to try to put links on YouTube to jump to each section of the movie. So we'll see if that works. You can pause to see what's available and to jump right to that. But I'm going to move right into the tutorial at this point. We're going to start with a template that looks rather blank, but then again, there's quite a bit of formatting that's filled out for you. We'll deal with page divisions later. So you want to make sure that you get the copy of this template. It's probably available on the lab website, or I might have made a link on the YouTube video also. Our final result is going to look something like this. Here's our data table. And we've got a title up here, and we've created formulas to populate all these cells. We've used a series fill. We'll go through all these things in the tutorial. And then we have values down here. We'll see about, maybe I'll leave these equations here for nice formatting for you, but you'll fill in the equations here, etc. And down here we have an example of all the column titles, explanation or formulas, as well as calculations, and then the value from trial 1. So this is our goal, is to create this spreadsheet with all the formulas, and also to create a D versus T plot, and then a final plot of displacement versus time squared, with a scatter plot and a best fit line, and then a theoretical line. That's a series 2, and this blue data is series 1. And then we'll create a physics equation based on the output from Microsoft for the best linear regression, the best fit line. And then we also have an equation for the predicted displacement. Okay. So let's start by creating all the things that we need for this data table. First off, we want to do some things for the viewing. It's a good idea to change the zoom factor so that this is more readable. We'll try maybe 200%. And then when I'm working on data, I don't like to see all the page margins, and so I tend to go down here and say normal view. And that's also available in the menu. We can do page layout or normal view. And I tend to like normal view. And I also like to double check that my toolbars are turned on, standard and formatting. And also that my formula bar and status bar are available. The formula bar is right here. It shows whatever the contents of the current cell are. So let's start with populating for trial 1 and start position, the series that will go down from there. So trial 1 goes to trial 2, etc. To do that, we're going to do a series fill down. So trial 1, we want to go to trial 2. Now I want you to notice a few things about the cell selection. If I put my mouse in the center of the cell and click and drag, I'm highlighting multiple cells. Now if I put my mouse on the border of the cell, on a Macintosh, this turns into a hand symbol, which means I'm literally moving the cell. Command Z on the Macintosh will undo. And then finally, if I put my mouse in the lower right corner, it turns into a solid plus sign instead of an outline plus. And that is the series fill. When I fill this down, it shows me a preview 1, 1, 1. That's not what I wanted. Instead, I want it to count for me. So as I fill down, I'm going to hold the Option key. And you see it's going to count for me. Let me zoom back out and just continue filling down until I populate my data table. Oops, one more. So that's called a series fill down. It saves a lot of time. Now the start position, I want to go 2.0 to 1.9, 1.8, 1.7. Yeah, I can count backwards, but I'd rather Excel counted for me. So in this example, well, first of all, if I fill this down, it's still 2.0. If I use the Option key, it's doing something weird, counting for me. It's counting, it sees that as 2, 3, 4, 5, 6. What I want to do instead is show Excel how I want to count. So I'm going to type in 1.900. Now I've shown Excel the series. And so I just want to fill this series down. And there it's counted for me. Now there's a shortcut. If I have a column directly to the left of my current data, if I highlight my series, I can double click right here. And when I double click, Excel will auto-populate down to the size of the array or the series, just to the left. So that saves a lot of time, especially if you have hundreds of rows of data. Let me do that again. I highlight the 2.0 to 1.9, put my mouse in the lower right, double click, and it fills down. Now the data that I have here is data that I took. And you're welcome to use these values for time 1, time 2, and time 3 for all the trials. But if you have your values available, I'd prefer that you took just a minute to type those in. But before you type them in, it's a good idea, while I'm selecting whole columns of data, let me zoom out here for a second. I like to highlight all the data. Okay, so we dragged from the center of the cell, highlighted all the data, and then right-click and choose Clear Contents. And then you can type in your data for time 1, time 2, and time 3. But if you don't have your data available, go ahead and use my time values. Now, average time appears over here. And on a calculator, we'd have to sum these up and divide by 3. And so we'll do the same thing here, but we'll use a function that's called average. So I can start typing average, and the spreadsheet gives me, hey, I think you might want average, or average A, or average if, etc. And so if I just choose average right here, it'll give me parentheses and puts my selection right in the middle of the parentheses. Now I could have just typed out the word average and not chosen that. Now I'm going to highlight from 1.31 over to the third value. And we'll notice that while I highlighted and dragged, it wrote a reference for me, C8:E8. And then when I hit return, it calculates the value. Now you can see that I could have said open parenthesis, this value plus this value. And by the way, Excel assumes a plus every time you click. Otherwise, you type in your own function, like I just did. Divide by 3, and I get the same result. So I'm just going to undo and do this again with equals average, down arrow to choose the average. And notice I just typed A, and it shows me all the possible functions that start with A that it thinks I might want. So I'm just going to go down, and hit return. And now the selection's in the correct place, and I highlight those 3 cells. I recommend not typing C8:E8 because sometimes we make mistakes when we try to refer to the cells. And by the way, right now when I'm choosing 1.34, that is cell known as F8. Okay, and that's, for those of you who aren't familiar with spreadsheets, that's column F and then row 8. Now I'd like to series fill this down, but I can double click and it will fill down the same dimension as the cells directly to the left. And what it did was it found the average for all T1 through T3 for every single trial. That's much quicker than using a calculator. And we'll skip the uncertainty and average time just now. We'll do average time squared next. So we're going to start with equals. And we simply click on the average, Shift 2, and squared. By the way, I should mention, if you haven't done this yet, you should probably pause the video and recreate all the steps that I just did. After I show a new function or a new concept, pause the video, perform the steps. Please do not watch the whole video and then try to do everything from memory. Just do it step by step. And now if I double click, it's not going to work because the cells directly to the left are not populated. So I've typed in my function equals, and I clicked on this cell and said squared, and I can go up here to the formula bar and see the square. And now I'm going to fill down by dragging from the bottom right. Now I've populated all the time squareds. And by the way, I may have fixed this beforehand. So you might have a bunch of pound signs. I've seen this happen to students occasionally, where they do their average function and then they get a bunch of number signs. Okay, and those number signs mean, oh, the value's too large with significant figures to fit within the display. So you just want to highlight all those values and decrease the decimal place until it's appropriate. Now for displacement, I want to create a formula that is start position minus final position. But before we do that, let's take a look at our constants. Looks like this is partially populated, and things are not formatted too well. Also, I want to notice an important feature of a spreadsheet, and that is in this cell known as C2, I have a value of 2.1. And yet it is displaying as 2.100 meters. That's a very important feature. I don't want to type meters in my formula bar, because if I type text up here, I will not be able to use this value in an equation. So I want to be careful to format the cells appropriately. Now for the height of the block, for my experiment, I'm pretty sure I had 0.0105. So 0.0105. That's the height of the block. And the distance between the supports, I had 1.000 meters. And it doesn't format it right for me, but we'll work on that in just a minute. And then right here, I want to have a new thing, sine theta. And sine theta is equal to, I want to take the height of the block, and I want to divide by the distance between the supports, h over L. And so I get this number. Oh, look, that's the same number. Yeah, because I divided by 1. But what's special is this number is dimensionless. So let's type in sine theta. Sine, I need a theta. Well, I'm going to close my parentheses and then type E equals H divided by L, which equals, now I'm going to go back here in between the parentheses, and I want to insert a theta right there. So this particular version of Excel has a nice feature where I can insert a symbol. So I just go to the Insert menu and choose Symbol. Now I've got all these symbol choices, and notice my selection is still there in between the parentheses. And so I can scroll down and find the Greek letters, and there they are. And all I have to do is click once on theta, and theta will appear. Pretty nice. I can go ahead and close my symbol. And by the way, this is also found right here with a little media browser. It looks like some notes and a movie and a picture. And you click on there and then choose symbols, and then you can sort by certain symbols. I could have just chosen Greek right there and found the theta this way. Now I'd like to left justify this cell. So I'm going to choose left justify. I could just highlight all of these and choose left justify. And while I'm at it, I may as well highlight all of these and right justify. Sometimes you have to choose it twice if one of them was already that way. So things are looking a little better now, but I want to add units. If I select this cell with the height of the block, I want to add meters to it. So I'm going to go up to the Format menu and choose Cells. And right now it's just set as a general. I can go into Number and say, well, give me, I actually wanted 5 decimal places because I could know the height because of the vernier caliper out to this next decimal place, which is 1/100th of a millimeter. But I want to add meters to it, so I'm going to choose Custom. And let me zoom in so we can see this here. I want to add meters here, so I'm going to start with a double quote on the keyboard. I like to put in a space just to give some room, and then open a bracket, meter, close a bracket, close double quote. So I've told Excel, hey, whatever number I type into here, leave it as a number, but add some units or some text to that number. And the nice thing is after you do this, it'll be saved in Excel as a potential unit. So you can see some of the other units I've used. And click OK. And now it's showing as with the proper sig figs and in meters. The distance between the supports, I'll do the same thing, but you know what? It is the same format as this one, final position. So I'm going to use what's called the Format Painter. Before I continue, I'd like to remind you that the 2.1 is important, that we do not have any text up here. If I type text into the cell for the actual value, I will not be able to use that cell in a formula. I will get errors from the spreadsheet. So Format Painter allows me to click on a cell that I like the formatting. I go up here to Format Painter, and then I click on the destination, and notice it added the units and gave me the proper sig figs. This number is dimensionless, and I'm not quite sure yet about the significant figures, so we'll work on that a little bit later. Now, I've got my value, 2.100 meters. I need to create a displacement calculation based upon start position minus final position. But I want to use the absolute value so I don't have to worry about negative numbers. Now, I don't know. ABS, and it shows me, oh, ABS. But let's say I don't know what function I want. I can click up here in the function browser, and the formula builder comes up. And here's most recently used functions. But I can see a list of all the available functions that are in Excel. And I can even type a search routine and look for a particular function. So Excel has hundreds of functions that are pre-programmed that take various inputs. But for this particular example, I know that I'm going to use the ABS. So ABS for absolute value. And now I want to say start position, so click on there, minus the first value for start position, and then we want to subtract the final position. So we click on the 2.1, and then close the parentheses and hit return. Now there's a problem. When I fill this cell down, oh, that worked. Bummer. I did something to this spreadsheet before I started, and I forgot to undo it. So let me take just a minute, and you can kind of see how this works. Insert name, define. I had already created a name called Final P, and so I'm going to delete that. Close. And now it doesn't know the name, so I'm going to start over. This is how it'll work for you. Equals start position minus the final position. And now when I hit return, this is what I wanted to see. Oh, I forgot the ABS. Silly me. Distracted myself. ABS. And then close the parentheses. Now, when I fill this cell down, just a few of these, I see that the numbers are all wonky. Oh, there's a pound value. When I click here, it's looking at C7. What? C7 is right here. Oh, and by the way, this is what happens whenever you refer a formula to a cell that has text. That's why we don't want to type an M in the cell. But this is a problem because I wanted to stick with final position. So there's two ways to do it. You kind of already saw one of them. But I want to change C2 to say $2. And that's called an absolute reference instead of a relative reference. You could think of it as a fixed reference or a constant reference. We want to always refer to C2. When I fill my formula down, I don't want the 2 to update. So I put a $sign. If I put a $sign right here in front of the C, it would allow me to fill my cells to the right or to the left without changing the C. But I don't need the $sign there. It does not hurt. But I'm going to leave it just in front of the 2. And now you'll notice when I fill this cell down, all the values will be proper. But there's an even better way, in my mind at least. I like this way. This cell, C2, can be renamed right here. So it's called C2, but all we have to do is just click in the C2 and type a name. Final _ P. And I kind of lost that off my video there. Sorry about that. So instead of C2, we just type up here and give this a name. You have to be careful with the names. You shouldn't call it B1 because that's already a cell. This is B1. So you have to be thoughtful in how you name these. And you cannot have any spaces or funny characters. So I use underscore sometimes. So final P and hit return. And now notice this is D2. But when I click here, it calls it final P. Which means when I create my formula, I can make this more human readable. I can just type final _ P. And if I forget how I spelled things, all I have to do is click on the cell and the spreadsheet writes in the name for me. Hit return, and now I'm going to fill this down. And by the way, if you do the quick fill down, make sure that this cell right here is empty and there is no value in it. We're going to use this cell a little bit later for the plot. All right, so now we're moving on to theoretical distance. Theoretical distance. Let's first build the predicted slope. We know that the slope should be 1/2 g times the sine of theta. I'm pretty sure that that's what we had shown on our graph, that we said the slope of displacement, as far as prediction is concerned, is 1/2 g h over L, which is the same thing as 1/2 g sine theta. So we want to calculate that right here in predicted slope. Equals 1 divided by 2, or of course 0.5. Then you have to do an asterisk to mean multiplication. 1/2 times g, which the expected g is 9.80 meters per second squared. But we're not going to type meters per second squared because that would be text, and the calculation cannot use text. Times sine theta. Well, here's my sine theta. Oh, but I've got a problem. I'm going to run into the same thing with a constant reference or relative reference. The relative reference means when I fill my formula down, it's going to look at C6, C7, C8, C9. So oh, but I'm not filling this formula down. Silly me. So it'll be okay. C5, and then we want to multiply by the t squared. So I click on the t squared value. And then hit no, I'm sorry, y'all. I need to clear my head just a bit. The predicted slope is just 1/2 g sine theta. I hope you saw that mistake as I was doing it. Oh, wow, somebody was nice to you. This cell is already formatted. So I'm going to go into the Format, Cells, and you'll notice on a Macintosh the shortcut is Command 1. And Custom was already chosen, the sig figs, and then meters per second squared. Now I've left a lot of significant figures, even though I may not know all those, because I don't want to have rounding errors. So I want to keep a number of significant figures for now. Theoretical distance. So I want to type equals the predicted slope, and somebody was nice and maybe already named it for you. If not, you'll want to name it first. The predicted slope multiplied by the time squared. That's what I tried to do a minute ago. I was getting too excited about this. And then I double click the bottom right and it fills down. And I want to make sure that this value is 0. This is null or nothing. And this value is 0. For average time is 0. Displacement is nothing. And theoretical distance is. Excellent. Now, I see a problem with significant figures. I'm just quoting way too many. So I'm going to choose these right here. Highlight those cells, and then I can decrease or increase the decimal. So I'm going to decrease the decimal and show this for now. We can discern how many decimal places uncertainty we have after we've analyzed all the uncertainties and error propagation. But this cleans it up and makes it easier to read. I should make a note right now about Excel and significant figures. If I'm showing 0.092, Microsoft is actually storing many more significant figures behind the scenes. So I want to show you this by increasing the decimal. And you can see that, oh, it's got plenty of digits for me to see, and pretty soon it's just the pound sign. And if I'm going to be performing manipulations on these numbers, what I'd like to do instead of allowing the spreadsheet to store all those significant figures is I want to wrap my function with another function that's called round. And the round takes the format of find the number or the formula and then a comma and how many digits you want. So I could say round that, and then let's take 3 digits and hit return. And now you can see that if I increase the decimal places, they're all zeros past that point. Now, if you're dealing with money, accounting, and you're not rounding when you're manipulating values with equations, like taking a percent or a ratio of a fraction of a dollar, you'll run into problems with rounding errors. And so it's a good idea to use round and then create that the rounding of the number. Now, I'm going to undo the round because I actually don't want it. I'm undoing a bunch of steps. Remember, Command Z will undo. The reason I'm going to undo the round for the theoretical is because I want this data to be perfectly linear, no scatter in it. And so it's okay with me if it carries umpteen decimals because I know that they're all truly on a line. Remember, I took this predicted slope, a constant, and multiplied it by all my average t-squareds. Here is where I might want to employ the rounding function, as well as here for the average time. So again, you just change this to say round, and then do your formula, and then comma, however many decimal places you want. So we're trucking along pretty well. Let's go ahead and make our plot next. We're going to make 2 plots. One of them is displacement on the y versus average time on the x. And the other plot is displacement on the y and average time squared on the x. We're also going to be looking at theoretical distance or theoretical displacement versus time squared on that same second plot. So let's make our first plot. Displacement versus average time. Now there are many ways to do this. I'm going to highlight the average time starting with the title and going down to the last value. And then on a Macintosh, I'm going to hold the Command key on the keyboard. The Command key is right here. It's next to the space bar. And it looks like this. So that's the Command key. So I'm going to hold that key down while I highlight the displacement. I do not want to hold that key down when I'm highlighting the average time. Let me clear this and just show you again. So I'm just going to highlight from title to the last value. Now I'm going to hold the Command key, so you can see that I'm holding Command, and highlight from displacement down to 1.6 and let go of the Command key. What I've done is I've told Excel the first selection is the X, and then the Command selection is the Y. And now you'll see how nice this new version of Excel is. Up here in the ribbons, I can choose charts. And then right here, I have scatter. When I click on scatter, it gives me various formats. And I want this one, scatter, with no lines connecting. And now I've got my first plot. And it looks quadratic. That's a good thing. So I'm going to right-click and choose Move Chart and create a new sheet and say D versus T. And now I've got this on my own worksheet. Notice my data table is just sitting right here. And my new plot is right here. Now I can click and drag, and I kind of like my data tables to be to the right of my plots to be to the right of my data tables, but it doesn't really matter. So I can just go back and forth between these two worksheets. The whole thing is called a workbook, and these are called worksheets. If I want to rename a worksheet, I can just click once, or right-click, and choose rename. I guess you can't see that because it went off the movie, but there's some different options here, and one of them is rename. So there it is, displacement. I don't have any axes titles, so let's get those on rather quickly. These are ribbons, and charts. See, there's an arrow here, and then it says chart layout and format, and those are purplified, and those are applicable to the charts. And I'm kind of liking these ribbons after I get used to them, because things are available and they're related to the primary function that you're doing at the time. So in chart layout, that's the option that we want. Oh, if you click it twice, that ribbon disappears. I want to turn on axis titles. So I just click right here on axis titles, and I choose horizontal axis title. I say title it below. And then while I'm here, I'm going to choose vertical axis title. Oh, I like the rotated title. So you can see it right here. So I just click, and I can forward delete or backwards delete, and then just type. Yes, let me see here if I can type today. Displacement, and then square bracket, meter. I don't hit return. Instead of I just click outside of it. If I hit return, I'll add a hard return there. And so now I click on the x-axis, and this is time measured in seconds. Oh, I did two of those. Now I'm supposed to add a text box to this plot that talks about the linearity. Is this linear, or is this not directly proportional? Is this some other function like a quadratic? I don't know if you saw what I just did, but I resized the graph. This is a scientific plot, so I want to make sure I'm filling up the page as best I can, because it'll let me see any kind of anomalies or patterns in the data much better than if the plot is really, really small. And so I like to fill up my page with the plot, the very first thing that I do. Now, to get a text box on here, this version of Excel is lacking that ability in its natural way. If I go up to Insert here, text box does not appear. Notice that if I go to a data table, I can choose Insert and see text box. That's a problem. There's a couple ways to get a text box. One of them is rather unnatural, and I don't really like it. You go into the media browser, if you remember that, and then you go into shapes, and then you can choose all or just choose rectangular, and then you choose a shape that's filled in. And then when I draw it on the plot, I can actually type in this. This is a text box. I didn't even type that correctly. Okay, so that's one way. And it's bluified and it's shadowed, and I don't know. I don't like that method. The next method I'm going to show you, I don't like so much either the first time around, but after that it's easier. What I've done up here is I've created a menu, called Insert. And I can just choose Insert, and notice there's the symbol. There's text box. And so now I just draw out a text box. Now I can type. This data does not appear to be linear. Now I can highlight all that data and change the font, make it bigger, easier to read. Oh, yeah, I didn't think I spelled that correctly. Appear. This data does not appear to be linear. Yada, yada, yada. How did I get this insert menu here? This is a handy menu when you're making plots. For some reason, Excel did not, in this version, create an easy way to get text boxes. I'm going to go up to View and choose Toolbars. So View, Toolbars, Customize Toolbars and Menus. And now within the customization, see, here's all commands. So I could actually add an XY scatter just right up here. Let me show you how this is done. We just take XY scatter and say, you know what, that's my favorite kind of graph. So I just put it right there. And now I've got this cool little button. Anytime I want to make an XY scatter, I can choose it. I want to, it'll take me just a minute. Built-in menus, scroll down just a little bit, and there's the insert menu. So we scrolled down here and we saw built-in menus, there's insert, and I just want to put that up here in the toolbar. If I don't want a menu, I can just drag it and remove it from the toolbar and it goes away. So what I've just done is I've customized my toolbar. So now you'll see I have an insert here and another one here, and I probably don't need two of them. I also grabbed the format because that kind of helps me when I'm working with plots sometimes. So I've got displacement versus time and a text box. This graph is sitting on its own worksheet. Sometimes Excel will make things look a little funny and it's hard to read the plots. And so I found the fix is to go up to the view, zoom, and choose selection, and now it automatically zooms the plot to fill the page. Now, one advantage to having this on its own worksheet is that when you go to print, so we go to print and hit preview, it's landscaped and it's full page. Okay, let me resize this so you can see and zoom out. So here's my piece of paper, and it is landscaped and filled the page. And Excel just does that naturally for you when the worksheet is filled with a plot. Okay, and that was done by moving the plot. So let's go on and make our final plot. Average time squared on the X, displacement on the Y for Series 1, and theoretical distance for Series 2. We're going to be careful because displacement is actually a scatter data, and theoretical is a line, but we want it on a scatter plot. So we'll go through this step by step. If you recall, I highlight the average time squared first, and this time I'm going to go down to the 0. We'll talk about why in a minute. And then I'm going to hold the Command key and highlight from displacement down to the null value. It's very important that your array sizes match. And then I'm going to hold the Command key again and go from theoretical down to 0. Now remember, when I highlighted the average time squared, I was not holding the command key. Just a standard selection. To find the first y value, I hold the command and highlight displacement, and then hold command and highlight theoretical distance. Now after those are all chosen, I can go up here to Charts and choose XY Scatter and then choose this one. Or, let's see what happens. We just created this new button, XY Scatter. That's pretty slick. Now I want to right click and choose Move Chart. New Sheet. D, see, you're getting pretty good at this, aren't you? T squared. I think we can do a caret in the name. And again, I like to move my plots to be to the right of the data table. I've got a fair bit of work to do on this plot. One, let's go ahead and stretch this out so that we're filling up the page. Two, we want to add a trend line to the data, because that's the displacement data. And three, we want theoretical distance to not appear as data points. No, because these are actually a line. I created this data by making it linear to begin with. If you remember, I took a constant, the predicted slope, and I multiplied it by all the average t-squareds, which means this data is not scattered. There's no random uncertainty. It has a fixed slope of this value, the predicted slope of, in my experiment, 0.0515. That means that I can take this data and rather format it. Instead of data points, I can format it as a line. Now there's a long way you can do this. You can go into format and then format the data series, and then go through all these things by turning on the marker line and then turning off the marker style. So we turn that off and we turn this on. But we don't want to do that because that's hard work. So instead, all we have to do is highlight the data. First, let me unhighlight and then highlight the data once. If you're having a hard time because your data and the theory are so close to one another, up here in the chart menu, in either the layout or the format, there's this wonderful selection here. You can choose the legend and see it's highlighted the legend. Or you can choose the vertical axis and see it's highlighted the vertical axis. You can format the vertical axis and go in and change the scale and all sorts of features for the vertical axis. So I want to go down here and choose the theoretical distance. Pardon me. So I've chosen the theoretical distance. And now I want to go back to charts. And for the XY scatter, I want to choose the smooth line or the straight line. It doesn't matter because I actually built this data to be perfectly linear. And look at that. Now the theory is showing as if it's an actual line because that's how I built it. If I wanted to change what's selected in the data, I could do it right here. Notice that it's series from the data table, and then it tells the cell references that I'm using. If you made a mistake and you're not seeing the origin, that means in your data, when you selected the data, you did not go down to the zeros. You don't have to redo everything. You could simply change this, selecting the theoretical series, and make sure you're going to cell 24. Because if you're going to cell 23, then you're not going to see the line drawn back to the origin, which was the prediction, that with no time squared, there should be no displacement. Now the data, on the other hand, I want to add a trend line to the data. The way I do that is I click once on a data point and right-click. It says Add Trend Line. Here's the form of my trend line. And I want to go into Options and Display Equation and Display to R-squared value. I do not want to set the intercept as 0. This is real data. I should see a vertical intercept, a systematic offset. I do not need to forecast either forward or backward because I asked Excel when I created the plot, the series that I put into the plot rather, I asked Excel, hey, if my time squared is 0, predict what the displacement should be using the linear fit. I don't know what that displacement is for my real data, so I've left it empty. And when I told Excel, plot all this down to the 0 and what I call the null value or nothing, it shows me visually the y-intercept. And up here it shows me that's equal to this value. Now we want to add axes titles, so we go into chart layout, axes titles, horizontal, below, vertical, rotated. And now I can just type in here. This is the same thing. Displacement in meters. Well, there's not a lot of room. I think that's because I resized my plot. So I might want to click on the plot itself and then resize it, giving myself a little bit more room for my titles. There we go. Oops. Sometimes the plots are a little squirrely with selecting things. And here I want to do some formatting. So here we'll learn how to do superscripts. Time, this is squared. So I just type a 2, and then open bracket and S2, and close bracket. And then just make this easier to see, I'm going to make the font size quite a bit bigger. This 2, I want to superscript it. So I hold the Shift key and I right arrow one time to highlight the 2. Now you could just use the mouse and try to highlight the 2, but I find the keyboard a little bit easier. So again, I could be, Command, oh, great. I just tried to undo. I moved it, but it wouldn't undo the move. Like I said, the plots are a little bit squirrely sometimes in dealing with text boxes. So I'm going to right arrow until I get to the 2 and hold the Shift, and then right arrow. Now I go into the Format Axis Title, and in the font choices, I choose Superscript. I would love to find a way to make a button for Superscript. That used to be there in old versions of Excel, previous versions, but it's not anymore. So I'll highlight the next 2 and Format Axis Title and Superscript. There we go. What else do I need on this plot? I need an equation of the line. So again, I'm going to go into the Insert and choose Textbox. We showed how to do that earlier in the movie. And then draw out a text box. And I'm going to type, but first let me make my font size a little bit bigger. Okay, so displacement, and you could type that out if you wanted to, is equal to 0.047, and we have meter second -2. I'm going to go back later and superscript that, multiplied by t squared, and then we add 0.052 meters. And then I also have a predicted displacement. Predicted is equal to 0.05152. I forget. It's on my data table. You probably remember. 0.052 is rounded. So we'll call this 0.052. And then meter second -2 again. Square bracket and then t squared. But this one has no y-intercept. So now I can clean things up. Let's go to predicted And then Command 1 brings up that, uh-oh, we're running into the problem. This is the problem that I was talking about. Text boxes and plots have a hard time. And I'm not sure how I'm going to recover from this. Maybe that's why I built this. Oh, man. That's why I brought in this menu. Font takes a moment, and now I can subscript. Oh. No. I wanted to superscript because I highlighted the -2. Superscript. There we go. Sometimes Excel gets confused with what it's doing with text boxes. And if you highlight something and you want to make it superscript or subscript, the format, see, it's saying grid lines. And I haven't highlighted grid lines. And that's just a bug. And so I found that if I bring in this menu, this is a bug fix, to bring in that menu, View, Toolbars, Customize, go into Built-in Menus, and find the first format that appears. And I say the first because there's a format that appears later on and it's not the right one. So grab the first format that appears and just drop that onto your menu system. So I've highlighted predicted. Now I'm going to format text and go into font. And this is a subscript here. But you get the idea. -2. Format text. Font. Yeah, bugs. Bugs. There we go. Let's see. Will it remember that font if I copy and paste? Not quite. Like I said, these text boxes are pretty goofy. Text, font, superscript. There we go. Oh, I've got one more here. Highlight the 2. And again, it should work just to go up to the format menu at the top of the screen and be able to choose font. But there's just problems. Maybe that's why they don't allow text boxes to be put on plots very naturally. And it looks like my spreadsheet has been outside the movie. I hope that hasn't affected too much. So things are looking a little better. You'll notice the grid line is kind of going through the text box. So if you highlight the outside of the text box, you can apply some paint color if you'd like to. And then finally, I want to go back into charts. And you'll notice that I don't see the expanded ribbons. And so I've recovered that sometimes just by clicking somewhere in the chart. And then these things populate. Again, I think that's a bug. And chart title. I like it to overlap. And here I can say, data and graphs, D versus T squared. And again, I could format that. Kind of like this little menu. It's easier to get to, although the font has to choose superscript. So now we've formatted the plot. We've got the 2 equations describing 1, our data, and 2, the prediction. I need to make another word about this. We would not want a trend line on the theory. If you take the theory data points and right-click and say Add Trend Line, you're making a large mistake, because what you're telling the instructor is that you do not know what the slope is, and you do not know what the vertical intercept is. But this is theoretical data, so we do not want to do that. We want to instead, no trend lines, but instead we want to format this to be a line. Okay, and we did that by choosing the data, and then we formatted it the quick way by the charts menu and choose scatter, and then chose this linear format instead of the scattered data points. So please remember that. Now we're almost done. We want to deal with some uncertainties, and I'll show you a couple more hints with inputting and formatting. But before we do that, I just want to add a title up here. So I'm going to highlight all of row 1. So there's all of row 2, there's all of row 1. I could choose 4 rows and say Insert Cells. And see, now I've got some more space to write things. Edit, undo Insert Cells, and I can just choose 1 row and say Insert Cells. Now I can type a title. Data and Graphs Incline Plane. But I want to make this a little bigger, so I'm just going to choose the font size. Let's make this 22 and boldface. Now I'd like to check into my page layout view, and I'm going to zoom out just a little bit, 75%, to see how things are broken down. And I see that, okay, I've got a nice title here, my data table, and then I have another data table down here to deal with measurements and uncertainties. And it's broken over 2 pages. This version of Excel does not have a very nice way of dividing pages. It has a page break, but I found that it has some problems. So instead, I'm just going to cheat. I'm going to choose row 27. And then when I put my mouse on the border of row 27, I can see that I can resize it. And I'm going to resize row 27 till it's almost filling this page. See how I kind of cheated? And then sometimes I'll even go in here to row 28 and just insert a blank row and then resize it if I need to. So I'm calling this cheating because it's kind of like being in a word processor and just hitting a bunch of hard returns for a new page. Like I said, Excel does have insert break, but there's problems with it. So now I've just put this on 2 pages. And by the way, something I've done for you before you open the template is in the page setup. I've said make this landscape and fit 1 page wide by 2 pages tall. Okay, and so it's automatically formatting things for 2 pages tall and 1 page wide. Save often while you're working on this data. So now I'm going to go back into 150%. Now let's look at 200%. We're essentially done with the basic format of the table. With the 2 plots, we've separated it into 2 pages so that we can print things nicely with nice page divisions. And we've got 1 plot and 2 plot. Now, regarding the measurements and uncertainties, I'm going to want a plus-minus symbol when I put in my measurement uncertainty. For my final position, my uncertainty was 0.00, I don't know. There was motion. If you remember, the glider was moving kind of fast, and so maybe it was 5 millimeters uncertainty. But it's in meters. So I can take this format, remember the format painter up here, click on the paintbrush, and then click on this cell. But I want this to be plus minus. So I'm going to go into Format Cells, and in the number Custom, I want to put a plus minus here before the 0.00. To get a plus minus, I'm going to show you a little trick. let's zoom in on this so we can see what's going on. When I hold Option and Shift, Option Shift, excuse me, I was holding caps lock. Let me turn off my caps lock. Option Shift, you can see that plus minus appears right here where the equal is. So I'm holding Option Shift and then plus minus. So again, I can do Option Shift equal sign, and that gives me a plus minus. And notice what it did. Plus or minus, and gave you the meters. Pretty slick. And so I can say OK. And height of the block, well, let's just copy this cell down. And the uncertainty here was actually, that's millimeters, that's tenths of a millimeter, and that's hundredths of a millimeter. And that's what I wanted, but I don't have it. And so I need to increase my number of decimal places up here in the format bar. Or I could just go back into Format Cell, and there's Number, Custom, and add the appropriate number of zeros. And then distance between the legs, I have a similar uncertainty to the final position. And I think this was like a 2 millimeter uncertainty because it was a 2-point measurement with parallax. Now sine theta. What is the measurement uncertainty in sine theta? That's a good question. I'm going to start with the relative uncertainty, but before, let's go up here, find the relative uncertainty in height. That's equal to the uncertainty in height divided by the height itself. And, oh, somebody already formatted this for me. I should multiply by 100 and then add a percent sign. But Excel has this cool little feature where you can just click on a cell and do percent. And it multiplies by 100 for you. Kind of lazy, I know, but I like that feature. And you'll notice that I've already added the plus minus. So it's 0.5%. That's the relative uncertainty in the height. Let's increase my decimal places a little bit to see what's going on. Yeah, I think we're okay. But I want to check something because sometimes I'm a little bit nervous, and this is why that percent is not good. I want to take this number and divide by this number. Yep, okay. So if we multiply that by 100, then we're at the right decimal place. A little bit nervous there. And here, I want to take the relative uncertainty as the uncertainty divided by the measurement. Boy, I shouldn't have formatted these for you. I think I might just take off these formats and let you struggle through clicking on percent or choosing to multiply by 100 and then going into the format and adding the plus minus. Here, to find the uncertainty in sine theta, I want to add the relative uncertainties for H and L. So equals that uncertainty plus this uncertainty is plus or minus 0.7. And let's reduce this by 1 sig fig. Now the measurement uncertainty, I'm going to do this one a little bit backwards. I'm going to take the percentage and multiply it by the measurement. And then I'm going to set this to show only one significant figure. And then left justify it. I'm going to go in here to custom and choose Option Shift plus. Now notice this is dimensionless, because if I take meters and divide by meters, I get a dimensionless number. Wow, look how many significant figures I can use for sine theta. So I want to increase my number of significant digits here. There's 4 zeros and then the 7. So 1, 2, 3, 4. So that's appropriate. So now I'm matching significant figures here with my uncertainty level. I'll let you go ahead and finish down here on page 2, populating all of these values, and then creating these formulas over here, and then finally typing down here. These are supposed to be samples from trial 1. It would allow someone to look at your data table and figure out exactly how you found average time and etc. Oh, I guess one thing we should do before we close, how to find the standard deviation. We want the uncertainty in time, and that comes from the standard deviation of these 3 values, T1, T2, and T3. So right here I type equals STDEV, and then open parentheses, and then highlight these 3 cells. Then close parentheses, and there's the standard deviation. And now I can just double click, and it auto-populates all the way down to there. And here, just for sake of reporting, I want to do equals average. I want to average all my times, because this is going to help me when I'm reporting uncertainties. My average time, and then right here I actually want to average up all the standard deviations. The standard deviation is finding how far, whoa, this is hard at this view. I should probably zoom out a little bit. How far from the mean will 2/3 of all the data points lie? And that's what the standard deviation tells you. And when I perform the standard deviation for each of these T1 through T3s and then average all of those, it tells me that my average time is 3.90 plus or minus 0.03. And we're going to use that down here when we calculate the measurement uncertainty in time, and the average time, and then the relative uncertainty in time. We're taking that average standard deviation, T1 through T3, to be the measurement uncertainty. There's a video available on the Data and Graphs webpage on the lab website that shows how to build all these values if you're not quite sure. But I think we've pretty much filled up all our time for this tutorial. I hope that you've paused often and that you perform the steps. To turn this in to your instructor, you need to save your file and email it to your instructor, and make sure you have a good subject with which class you're in and all the names of the people that worked on this together. Or you can show this to your instructor in the classroom. It does not help the instructor to have a printout, because your instructor is actually going to be checking your formulas to see if you've watched this tutorial and you've filled everything out correctly. So, hope you've learned a lot from this tutorial. If you have other questions, please don't feel, you can ask me and I'll create other videos, short videos to show you other things that maybe I have forgotten what to do, and maybe I forgot something, and then I can show you that and add it to the tutorial, and people can benefit from that. So hope you can use Microsoft Excel for lots of other things. I'm planning on creating another video for the Windows versions that's called 2010, and also possibly OpenOffice, openoffice.org. It's free, and I might create a video for that. I guess I can show you before I close what my final plot looked like, what my D versus T plot looked like. I guess I've lost the video here. And then what my data table looked like. And down here are my sample values. Have a good day.